introduce today. So do you guys know about Professor Yang? Have you guys ever taken Professor Yang's course? Okay, first I would like to clarify this. So there are two different agreements. Okay, the first one is okay, student mess up. Please turn to this page. Okay. Okay, there are two agreements. First one is in 1992 in Rio. Okay, in Brazil. Okay, this one is the first. This one is the first agreement about the greenhouse gases. But the problem is this one is non-legal binding. This one is non-legal binding, which means you don't need to obey. Okay, it's just some guidelines for people to follow. Although 160 country signs, but there was no legal binding for this agreement. Okay, so another one about greenhouse gases is set in 1997. This is called Kyoto Protocol in Japan. Okay, and this one is the first legal bindings. Understand? I have some. I put some explanations in our online group last week, right? Okay. After that, I remember we finished this. Okay. So today we will start with acidic air pollution. So first of all, I want you to define what are acidic air pollutants. What are acidic air pollutants? Any idea? 有没有那个名单？对，名单。Lorena here. Lorena, can you think about any acidic gases? Do you have any idea? How about like sulfur dioxide, right? So the acidic air pollutants, including the gases, mainly sulfur dioxide, and NOx. And we all know the buffer is the water is a great buffer for our environment, right? So if those acetic gases, okay, rain on the lake, you will lower the pH values of the lake or rivers. Okay, not oceans. Because oceans too huge, right? So it's going to. So if the pH change, it's going to reduce the buffering capacity of water, right? So you're gonna have some environmental impacts for those acidic air pollutants. And also in my release, the maker, okay, so this is not AI, okay, this is not AI. Professor Young is the expert of AI. This is aluminum. For example, like aluminum. Okay? For example, like aluminum, which can lead to toxicity, right? Which make the water and the soil toxic. Okay? And it's going to be harmful to organisms, including human beings. So in the United States, the large regions, especially in the northern east United States, are already affected. Okay, so this is what I'm talking about, right? The sources of those acidic gases, including like sulfur dioxide, and NOx. And if they combine with water, for example, like sulfur dioxide combined with water, it will produce sulfurous or sulfuric acid. The same for NOx. You will produce nitrous or nitric acid. Okay? Okay, let's start with sulfur dioxide. Okay, let's start with sulfur dioxide. So last time I already mentioned anthropogenic. That means human being. So anthro means human. Progenic. So that means those sulfur oxide came from the human activities. Okay, naturals, for example, like from volcano. Volcanoes. So which you cannot avoid this. A human being does a lot, right? Like coal burnings, fossil fuel burnings. Like fossil fuel burning. Okay? Okay, as I just mentioned, so compare with this two. So this one with 3 oxygen. So we call this sulfur, OUS, sulfurous acid. And this one is known as sulfuric acid. So OUS with 1 less oxygen. Okay, OUS with 1 less oxygen. So, sulfur oxide will react with water. We call this hydrextions. Okay, we call this hydrection, which means react with water. And also, sulfur oxide can be oxidized to sulfur, this sulfur group, right? And it can be catalyzed by metals. Okay, it can be catalyzed by metals. And also is the product of photochemical reaction. Okay, which is driven by the sunlight. Okay, which is driven by sunlight. So what can we do for this? Okay, if you have ever taken general chemistry, right, or you are ready for that, we can use something called LIM. So LIM is calcium oxide, right? So we can use LIM to do neutralization. So we can use LIM, CaO, to neutralize acidic gases. Okay, so we call this, actually, let me give you the professional terms for this. So we call this flue gas in desulfurization. So we call this process using LIM to neutralize acidic gas through gas desulfurization. Okay. So the T here is not Tom. Okay. The T here is Tera, which means 10 to the power of top. Okay, so the natural will produce 10 times 10 to the power of top grams per years due to like eruption of the volcanoes. And we human beings make even more for this. So everyone okay? If yes, I'm gonna move on to the next slide. Okay, sulfur oxide, SOx. Okay, so the X here means the number. Okay, means the numbers. For example, like this one is sulfur dioxide, and this one is sulfur trioxide. And it's the main, one of the main components of acidic pollutants. The other one is not. Okay, and normally, okay, this is very important. Put a stop here. Okay, usually they are found in association with particulate matters. Okay, as I mentioned previously, for example, this is the particulate matter, right? So the sulfur dioxide coated around the particulate matters. And the particulate matter can penetrate into your lung. And the moistures, which mean the water parts of your lungs, will do the hydrations. Okay, so you cannot so you will produce like sulfuric acids or sulfuric acids, so you can damage your lung. So as I mentioned, is that sulfur dioxide is the precursors of the fine sulfate particles. Okay, which make up is a major portions of pollutant. Okay, low in many cities. In concern to damage health. Okay. So concentration are higher by a factor of 5 to 10 in the number of cities in Eastern Europe, Asia, and South America. Normally due to the core use of the heavy diacetyl chocolate. I don't know if you guys know about this. Before the electric car came out, the diacetyl car was very popular. Okay, I even have one. Okay, but the problem is the diacetyl, okay, will produce lots of carbon dioxide and associated with particulate matters. And also, okay, it is the major component of acid rain. Okay? Due to the hydrations, right? Due to the hydrations. So the sulfur dioxide is also a major component of acid rain. So sulfur dioxide adds very quickly, probably within minutes. Okay, within minutes after exposure. So it will cause some health effects, especially for your respiratory system. 呼吸系统, okay, especially for your respiratory system. Okay, especially for your respiratory and cardiovascular systems. Okay, the health, because as I just mentioned, right, you're gonna penetrate deeper. Okay, carbon dioxide cannot penetrate deeper with particulate matters. With the help of particulate matters, you cannot penetrate deeper in your lung. Okay, into your respiratory traits. So the passion with edema, 气喘. Okay, the passion with edemas, okay, is even more vulnerable even more volatile. Okay? And even, take a look at this. Okay, if ozone, this ozone also present together with sulfur dioxide, it's gonna be even worse. Okay. Even stronger, the effect will be even stronger. Okay. So the combined pollutants, combined sulfur dioxide and ozone. Okay, the combined sulfur dioxide and ozone, the effect become even stronger, even stronger. Okay, so this paragraph, this slide indicates the toxicity and the danger of sulfur dioxide. So everyone okay with that? Finish?
我用一个策略，就是说，我怕他们睡着，所以我都有弄一个空的，红的部分就空的让他们填。对，这样，因为之前他们都会说打瞌睡，所以我就弄那空的给他们填。
Everyone finish? May everyone? Everyone okay? Okay. So you're also okay with this slides, right? Okay. So let's do this example together. An ENO's course is burnt at a rate of 1 kilogram per second. If the analysis of the probe reveals a sulfur content of 3%, so what is the annual rate of emissions? And if we assume about 5% sulfur ash. So I'm gonna give you 1 minute. Okay, I'm gonna give you 1 minute to think about how to solve this question.
然后我还会给有些习题啊，就是他们很多人都不买书，所以我有时候会给那个习题，让他们课堂至少想一下，然后回家再思考。我会用这个策略，这样学生比较不会打瞌睡。
Okay, 1 minute. 1 minute. All right? Okay. Okay, time's up. Everyone, please. Everyone, please look here. Okay, look to the screen. So let's see what we have here. Okay, first we have this. So what's this? This is the probe burning rate. And also we have sulfur content. 3%, right? And we have 5% sulfur remain in ash. Okay, sulfur ash means the sulfur remain in ash. Understand? So it's about 5%. So what's the question? So the question asks us the annual rate of emissions. So what's the annual means?
Alina? Alina, is Alina here? Alina, what does annual mean here? This is just English. So what is annual? What's annual? That means every year. Yeah, good. Yeah. The annual means every year. Okay, so let's take a look. Okay, first of all, let's do, let me enlarge this. So first of all, let's do mass balance, right? So the sulfur in equals the sulfur in ash, okay? And also the sulfur in carbon dioxide. Okay, the sulfur in carbon dioxide. Okay, so as we just learned, so it's burning. So it's a oxidation. Sulfur react with oxygen becomes sulfur dioxide. Okay, and the sulfur is 1 times 0.3. So that means every second the sulfur input is 0.03 kilograms. Okay? So, but we are talking about every year, annual, right? We are talking about every year. So, this is seconds. So we need to change into day. Okay, we need to change this into days. So we times 86,400 for 1 day. And 1 year we have 365 days. So this is what we have. And convert into kilograms. And this is what we have. So for sulfur in. For sulfur in. So this is step 1. I would call this step 1. Okay, to convert sulfur into year. So step 2. So we are looking for sulfur loss in ash. Okay, the sulfur loss in ash. So, and as we just said that we only have 5%, which means 0.05. Okay, 0.05 in ash. 5% sulfur in ash. So the 0.05 means 5%, and times what we just got. Okay, so this is the sulfur in ash. This sulfur in ash. Okay, everyone? So based on the mass balance, then we can find out the sulfur dioxide. We just use sulfur in minus sulfur ash. Okay, or you just use 0.95 times this amount. This amount of weight. So this is what we have here. Okay. But the problem is this amount is not. Okay, this amount is not sulfur. Okay, this amount is not sulfur. I'm sorry. This amount is just sulfur. This is just sulfur. But the question is asking the sulfur dioxide. Right? So we need to calculate, because the question is asking the sulfur dioxide emission, right?
And what we got was in step 3, it's just sulfur produced every year. Okay, so find out the molecular weight of sulfur dioxide, 64. Okay, and 64 divided by 32. Okay, the 32 is the atomic mass of sulfur. Okay, so and times this amount, and this is what we got, and this is what we got. Okay, so the 64 over 32, this is the ratio. This is the ratio of sulfur dioxide over sulfur. Okay, so finally, this is just documentaries. Okay, this is just a documentary. So the finally we got 1.8 times 10 to the power 6 kilogram per year for carbon dioxide emissions. Understand? Tom? Why I times 2 here? Why times 2? 64 over 32 is 2. Why times 2 here? You know? You know the reason I times this?
We use the amount of sulfur dioxide over the sulfur, so it's times 2.
Yeah, because based on this equation, sulfur is 32, right? Sulfur dioxide is 64, which means the mass of sulfur dioxide is twice of sulfur. Okay? But in this question, we are not asking about sulfur. We are asking about the emission, the amount of sulfur dioxide. So in step 3, although we got the mass of sulfur, but we still need to times 2. Understand? We still need to times 2 to get sulfur dioxide, the amount of sulfur dioxide. Everyone understand? Okay? Just a ratio thing. It's not more. Okay? This is not more. Just a ratio thing. Okay, just a ratio. Okay, because the mass of sulfur dioxide is twice of sulfur. Understand? For example, if this become like, well, that gonna be very complicated. Okay. Okay, let's take a short break. Okay, let's take a short break. So let's have a 5-minute break. Okay, let's have 5 minutes break. So it's 2:10 to 2:50.